Hi everyone, welcome to my new video where I would like to present you two different approaches to different patterns to deal with a right to be forgotten problem. So to summarize this problem, right to be forgotten idea is that you can ask any service you are using to remove your all personal data like birth date, like first name, last name, and address, and any other PII information. So to do that, if you do some small data processing, and probably you have only one or eventually two databases, you can perform the delayed operations, and it won't be a very time-consuming operation. But if you have some big data scenario, so hundreds of gigabytes of thousands of terabytes of data, it can be less efficient because yes, you will need some indexing layer, and you will also need to know what are the fields to remove, and you will also need to run a distributed data processing on top of it to rewrite the data of the users you want to forget. So to overcome this kind of limitation of this requirement to use the distributed data processing on top of big volumes of data, I was looking for some alternative solutions, and the first one I found was in let me find this great book about BigQuery. Yes, that's I found it in the Google BigQuery, the definitive guide, and the idea is called crypto shredding. So the crypto shredding uses kind of encryption keys, cryptographic encryption keys for sensitive data of the user, so that if a user wants to be forgotten, you simply need to remove the key belonging to his account. So to schematize that, we can say that we will have two stores. So the first store will be the store containing the encryption keys, and we will have one encryption key per user, and on the other side we will have our, let's say it, functional data store that will be queried by the end users or used by external applications. And what's the idea for the crypto shredding? The idea for the crypto shredding is to encrypt, as I already said, to encrypt the sensitive data of the user with his key, so we can have different things. And when you will read this information, so we will use this key for the encryption, and we will also use it for the decryption, so that the user, of course only if it's authorized to, will see the clear data, so yeah, clear PII data. And now what happens when a user wants to be forgotten? So when a user wants to be forgotten, everything you have to do is to simply remove the key, so that even though you ask the functional database to return PII information of the forgotten user, it will be still encrypted. You will not be able to decrypt it. Of course, this approach, even though it's look very easy on this scenario, on this very simplistic scenario, it has some important drawbacks, and to not bother you with too long video, I put these drawbacks in the article which is linked just below. The second approach that we can use, so remember, we can either physically overwrite the data, which can be time consuming and also costly, because you will of course need to pay the compute power. We can use the crypto shredding, which is a smart way to store sensitive data encrypted that will be lost, of course, when the user wants to be forgotten. And the third alternative, so the second alternative currently that I found, is the use of vertical partitioning. So what's the idea here? So you certainly know the horizontal partitioning when you, for example, ingest or synchronize some data from an Apache Kafka topic to a S3 or an object store or a data lake, and you partition this data by year, month, day, and hour, so that you can query only a relevant subset of data in your processing. So thanks to that, you can build smaller jobs that will execute much faster, and that will give you a feedback in a kind of micro batch semantic. You won't need to wait the end of the day to process the whole bunch of observations to get some insight. But the horizontal partitioning is not the single partitioning you can use in data engineering. You can also use the vertical partitioning. So the vertical partitioning is a bit different. In horizontal partitioning, you partition the whole rows, the whole events, the whole observations. So if you get some event 1, you will of course extract the time from it, and later you will put the whole event 1 to 1 place on your data lake. In vertical partitioning, you will do it a bit differently. So still, you can use vertical partitioning, of course, together with the horizontal partitioning. So we can say that we will do the same. So we will extract the partition information of this event, but instead of writing it as a whole, we will divide it in two different parts. So in the first part, we will store everything which is not PII data, which is not user-sensitive data. So we will do like if 2 no PII in this location, and for what is the personal data, we will take it from this place and we will store it elsewhere. And thanks to that, when a user wants to be forgotten, you need only to process these relatively small dimensions of this user, because you can imagine that if somebody has an address as physical address or first name, last name, yes, it won't change it very often, meaning that here you can store it only once. Of course, it requires a bit more coding effort at the beginning to deduplicate the data, but anyway, it's still possible. And thanks to that, you have small data set to process and remove the PII data of a specific user and rewrite it just here. And of course, this PII data can be horizontally partitioned. So if for whatever reason you have the things like IP address or geolocation information that can change from one day to another, of course you can put it in the horizontal partitions so that you can correlate them easier. But if you have some static data, like I said previously, first name, last name, maybe physical address, the things that won't change very often, you can put it to some very static data store, and you can have a kind of PII slowly changing dimension that you will of course join whenever you will need them in the processing. But if it's not the case, so if you don't need it, obviously you can process your data much faster, because you will have much less data to load. And of course, if this data is not changing very often on this no PII storage, you will store less data, and obviously you will pay less your storage costs, even though nowadays the storage costs, as you know, on the cloud are not very expensive, at least for the object storage solutions. And so generally those are two alternatives I found to this right to be forgotten problem. And as I said previously, I won't bother you here about the pros and cons of these approaches, because there are some pros and cons that you should adapt to your own need, because yes, it will not fit everywhere, and you have to challenge these solutions for your data system. So if you want to discover these pros and cons and also more schemas of these two alternatives, I invite you to the two articles that are linked in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.